Hey, my name is Disha Nayak, and I'm currently in Miss Tadros' Grade 12 Advanced Functions class. And today I'm going to show you how to step-by-step solve a very important mathematics question that is currently on page 378 of Nielsen's Advanced Functions Mathematics textbook.
Like a kid and a teddy bear, like a leaf blowing in the air. Could you carry me? Could you carry me?
So this graph is representative of the current scenario of question 8 in the textbook, with the y-axis representing temperature in degrees Celsius and the x-axis representing time in hours. So question 8a asks us to find a possible equation for the temperature of the surface water as a function of time. So, to find this equation, the first thing we need to do is analyze this graph. So question 8a asks us to create an equation for this question. So my strategy right off the bat is to create a graph, because that way you can solve for the variables you need to create an equation. So from the graph, I can see that my amplitude is 3, my equation of an axis is 22, the period is 24 hours, and given its sinusoidal shape, the function is a negative cos x function. And for the graph, I've also labeled my axes x-axis for time in hours and y-axis for temperature in degrees Celsius. So now that we have the values that we've solved for, we just need to plug it into our base function. But when doing that, we seem to be missing one value, the b value. Now, what is the b value? The b value is not the period. The b value is similar using our period, but the b equals 2 pi over the period. So 2 pi over 24 equals pi over 12. And since we have 0 phase shift, so no h value, we can create our equation by subbing in the variables. So if we let c represent temperature in degrees Celsius and t represent time in hours, we can create an equation that c at t equals negative 3 cos x pi over 12t plus 22. So for question 8b, it asks us to solve for the average rate of change, or AROC, which is basically the slope from point A to point B to find the rate of change exactly during that period of time. So question 8b wants us to find the AROC from sunrise to noon. So I know one point has to be at sunrise and the second point has to be at noon. And that's my first step to start the question. So our strategy to solve the AROC right off the bat is to find 2 points and solve for any of the unknown variables. Thankfully, we already have our point 1, which starts at 6 a.m., which is at 0 at 19. So our first point is at 0:19. And our second point at noon, which is 6 hours from 6 a.m., is at 6 with an unknown variable y. So simply, we use our base equation that we solved for in 8a, set it equal to 0, plug in the values that we know, and solve for the equation. So once you go through that step-by-step format, you can conclude that at noon, the surface temperature of the water is 22 degrees Celsius. But that is not the end of the answer. This is when the slope equation kicks in. Yep, AROC has to do everything with slope. So we use our point 1 and our point 2 and plug it into the equation y2 minus y1 all over x2 minus x1, which is our slope equation. And if you solve for that, we find the answer of 0.5. Therefore, now we can finally conclude that the AROC, or average rate of change of the water's surface temperature, is 0.5 degrees Celsius per hour from sunrise to noon. IROC, instantaneous rate of change, cousin to the average rate of change. Close, but not the same, because the IROC works around tangent lines. And the tangent, we're trying to find the instant rate of change exactly at one point. But you see, where it's similar to the AROC is that we still need a slope. But since we want to find the time exactly at the one point, we're going to use 2 points as close as possible to the point we're looking for. Now, question 8c asks us to estimate the instantaneous rate of change. So, at 6 p.m. is basically 12 hours from the start, which seems to be at our halfway point, which is at the maximum. So, if I were to estimate the instant rate of change at that point, I would have to say that the rate of change is 0 degrees Celsius per hour, because at the maximum, as we learned, there is no increasing or decreasing rate of change. It is completely 0. But for the sake of helping you out, I will solve for it anyways, and we'll see if my estimate was right. So since it is 12 hours from now, we want to select points as close as possible. So our point 1 is 11.999 G, because we do not know that value. And our second point is 12.001 N, because we also do not know that value. So if we start out with point 1, we can use the same base function that we solved for in question 8a. Plug our known values into the equation and solve. So C at 11.999, if we solve for that, equals 24.999. And then solving for point number 2, if we use the exact same steps, we plug in the value that we know for and solve for the temperature at that point, we get the value of 24.999. Curious. But we are not done yet. Yes, it's time for our trusted slope equation. I told you it was similar to the AROC. So we use our y2, which is 24.9999, minus y1, which is 24.9999, all over x2 minus x1. And then we can find that equals to 0 over 0.02. So I bet you can already tell that the answer is probably going to be 0. And yes, therefore we can conclude that the instantaneous rate of change at 6 p.m. for the water surface temperature is 0 degrees Celsius per hour. So I can also conclude that yes, my estimate was right. The instantaneous rate of change is at 0 degrees Celsius per hour because the point is at its maximum. Climate analysts often use AROC and IROC equations to solve for global temperature shifts and changes.
Oh, hey, it's Disha. I hope after watching this video, you now know how to properly and step-by-step solve these mathematics questions. So if you were having difficulty solving that question in the textbook, I really hope this video has helped you. Well, I don't know about you, but I think that's enough math for one day. So, good night, everybody.